Hello guys, let's continue from where we stopped. Uh, 2021 YGC past question paper on physics. So we've done up to 1 to 40. So into this class, we are going to start from question 41. Question 41 says, uh, a stone is thrown vertically, horizontally with initial velocity 15 meters per second from, from a tower 20, 20 meter high. The tower is 20-meter high. So the tower is 20-meter high. How long does it take to reach the ground? So we are asked to calculate the the time it takes, right? The time taken to reach the ground. So let's assume here is the tower. So let's assume here is the tower, and in that case we have the ground, isn't it? So we are told that the height of the tower is 20 meters. So if the object is being thrown, it will follow a parabolic path in this manner. So this is the horizontal velocity u, which is equal to 15 meters per second. So at every point of the motion, the horizontal velocity is the same, which is 15 meters per second. What keeps changing is the vertical velocity, which is under the influence of gravity. So if here is V1, for instance, at this point, here is TU, and there will be a change here. Here is V2, and so on, and so forth, till it gets to the ground. So you're looking for the time it takes to get to the ground here. So before the object was thrown, the initial vertical velocity is 0. So we have initial vertical velocity, uh, I call it V, vertical velocity is equal to 0. So, and the height h here, the height h is said to be 20 meter. So here is the initial horizontal velocity, which is u, but initial vertical velocity here is equal to 0. So we have three formulas that we use in solving this type of question, motion under gravity. So we have h is equal to u plus or minus half gt squared. So are we going to use plus or minus? We're going to use plus because the body is falling. If the body is thrown upward, we use negative. So in that case, this implies we're going to use h equal to ut plus half gt squared. So I can write this formula to be as h equal to the initial vertical velocity, which stands for u, initial velocity, here initial vertical velocity, vy, multiplied by t, then plus half gt squared. So what is my h? From here, h is 20 equal to initial vertical velocity is 0. So I have 0 multiplied by t plus uh, 1 over 2 multiplied by g, which is 10, multiplied by t squared, which we are looking for. So 2 here, 1, 2 here, 5. So that implies I will have 5t squared equal to 20. So divide both sides by 5. Divide both by 5, we have this. So which implies that t squared is equal to 4. So if t squared is equal to 4, in that case, let's come here. We have t squared equal to 4. That implies t is equal to root of 4. So t is equal to 2 seconds. I hope this is understood. So in that case, our correct option here is option A, which is a 2 second. I hope this is understood. So moving on. Now, question 42 says, Which of the following statements is not a characteristic of a plane progressive wave? A plane progressive wave, that is a traveling wave, something like this, all right? So we have something of this nature, right? So energy travels out through the medium. That is correct. Wave is said to be a disturbance that transfer energy from one point to another without causing any permanent displacement of the material medium itself. So energy is being transferred as it is moving, a progressive wave. Option B says neighboring point along the profile possesses different amplitude. Option C says neighboring point along the profile possesses the same amplitude. Option D says neighboring particles vibrate with different phase. I think the wrong here, you're looking for not a characteristic. The one that is not characteristic is B. Because the neighboring point along the profile possesses the same amplitude. What is amplitude? The distance from what? From the maximum position, the maximum displacement of the wave particle from the equilibrium position, right? From here to this place is a amplitude in a positive direction. Again, from here to this is amplitude in a negative direction, right? So it's amplitude in a negative direction. So neighboring point along the profile have the same amplitude. Like this point here have the same amplitude at this point here. Let's call this one point A and call this one point B. They have the same amplitude. Likewise, this here and this particle here. The next one is neighboring particle vibrate with different phase. So if you have particle D vibrating in this direction, right? And particle E in this direction vibrate in this direction. So they are different phase. Are we together? So neighboring particle vibrate with different phase. So the correct option here is option B, which is wrong because we're looking for the wrong option. Are we together? Okay. Question 43 says, the electrons in a cathode ray tube are produced by A, heating filament, B, ionization of the air, C, applying a magnetic field to the Y plate, D, applying an electric field to the X plate. The correct answer here is they are produced by heating element, right? Through what is known as a thermionic emission. You know, thermionic emission is nothing but the emission of electron from the surface of a metal after it has been heated. So after it has been heated, and that stream of electron coming from the cathode electrode, that is why it is termed a cathode ray, because the stream of the electron are emanated from there. Are we together? So the electron is in a cathode ray tube is produced as a result of the heating filament, right? So that is option A. Question 44 says, which of the following statement about distance and displacement is not correct? Is not, take note, is not correct. So we're looking for the wrong one. So displacement is a vector quantity, is correct. Distance has a dimension of L, is correct. Displacement is measured in meters, is correct. Distance is a vector quantity, wrong. Distance is a scalar quantity. Therefore, the correct answer is option D. I hope we are together. Now, question 45 says, a note produced by an instrument are distinguished from a similar note produced by another instrument by the A, intensity, B, pitch, C, overtone, D, loudness. The correct answer here is overtone. To start with, what is overtone? Overtone is a kind of other frequencies beside the fundamental frequency that exist or occur in a musical instrument. A note is just synonymous to your voice or the sound you heard when any musical instrument is being played. Are we together? So that is a note. So what differentiates a note played by a piano and that played by violin is the overtone. Overtone is like a special sound associated with every musical instrument. For instance, you and your friend might say the same word, which is in musical instrument, that the same word you say or sound is known as notes. For instance, if you and your friend say hello, even if it is of the same pitch, or that is pitch simply mean how high or how low a sound is. For instance, you have a high pitch when whistle is blown, but we have a low pitch when drum is beaten, right? So uh, your overtone is a special sound associated with each or every instrument, musical instrument. So if you and your friend say hello, whether you say it louder or lower, one can distinguish your sound from that of your friend. So what made it so is the overtones, your special way of sounding. So the same thing is applicable to musical instruments. So a note produced by an instrument is distinguishable from a similar note produced by another instrument by that uh, quality known as a overtone or characteristic known as a overtone. I hope this is understood. I took my time to explain this for a better understanding. So that is question 45, and the correct answer here is the overtone. Just take overtone like a special sound associated with every musical instrument. Okay. Question 46 says, according to Pascal's principle, the pressure in a fluid is always A, dependent on density of the fluid, B, distributed partially in all directions, C, transmitted equally in all directions, D, increase with height. The correct answer here is that it is transmitted equally in all directions. So, question 47, which of the following set of quantities have members which are all vectors? So, your ability to understand this, if you have your basic fundamental physical quantity and derived, followed by vector and scalar understanding. So, pressure, is pressure a vector? They say we are looking for ones whose member are all vectors. So anyone that has a single member that's not a vector, it has already cancelled that particular option. So here, pressure, energy, and force. It's only force that is a vector here. So this is wrong. So this is wrong. B, force is a vector, displacement is a vector, momentum is a vector. So I think this one is correct. Let us move to the next option and see. Distance is a scalar, so automatically this is wrong. Density, volume, and weight. Only weight is a vector here, the rest are scalar. So the correct option here is option B. I hope we are moving together. Okay. Moving on, question 48. If the relative humidity of the atmosphere increase, the rate of evaporation of sweat from the human body, A, decrease, B, remains the same, C, increase and then decreases, D, increase. The correct option here is option D. What is relative humidity? Relative humidity, humidity actually tell us about the amount of water content in the atmosphere, the moisture content in the atmosphere. So now, if you have much water content in the atmosphere, example during the rainy season, then the rate of evaporation will actually decrease. The rate of evaporation will increase if the amount of water content present in the atmosphere is lower. Are we together? So the correct option here is D. The rate of evaporation decreases when the humidity or relative humidity in the atmosphere is high. Are we clear? Okay. So question 49 says, which of the following factors is not among those that determine the resistance of a wire? Take note. It says it says factor that is not among. So we are looking for the odd among the rest. So option A, mass, option B, cross-sectional area, option C, length, option D, material. So here are the factors in which the resistance of a wire depend. One is the length, it depends on the length, it depends on the cross-sectional area, depend on temperature, and depend on the material, right? So for according to the relationship, we have R is inversely proportional to the cross-sectional area, right? And this R also is directly proportional to the length of the cross-section or length of the wire. So when you combine this, we have R is proportional to L all over A. From here, this implies R is equal to rho L all over A. This is our famous formula where this is known as resistivity, which is equal to RA all over L. So the correct option here is option A. Mass is not one of the factors in which or that determine the resistance of a wire. I hope this is understood. Don't forget to remember this formula. We can use it for calculation to find the resistance, resistivity, cross-sectional area, as the case may be. Okay. So question 50 says, which of the following scientists suggests that moving particles exhibit wave properties? So Isaac Newton is associated with law of motion. Ernest Rutherford is associated with nuclear physics, right? Same to J.J. Thomson. So the only odd here, assuming you don't even know the scientists and you know some of these ones, the only odd here is Lewis de Broglie. Are we together? So he is the one that suggests that a moving particle, that is the dual nature of a wave, it behaves as a particle, it also behaves as the dual nature of matter, right? It behaves as a particle and also behaves as wave. It behaves as a particle because it has mass, therefore it has a momentum rather, and it behaves as a wave because of the existence of a wavelength. So I think we come to the end of 2021 GCE past question solution series. So see you in next class. If you are new to this channel, please ensure you subscribe so as to be among the first to be notified each time I drop a new video. Thank you, God bless you, and see you in the next series of solutions.